What's up, guys? So we've been spending a whole lot of time learning some new stuff. We're learning the box method to multiply and divide. We're factor by grouping. We're using synthetic division, and just a whole bunch of other stuff. So we're going to take some time and kind of review so we can get ready for our quiz. And we're just going to go over some of the solutions to the review we gave you. So looking at the first one here, we're multiplying 3x minus 2 times 5x squared plus 6x minus 4. So a good way of doing this is to use the box method, right? So we put our factors here, this 3x minus 2, that's going to be put on the side. Then the 5x squared, 6x, and negative 4, that's going to be put on top. Then all we have to do is multiply the side by the top, right? So we do 3x times 5x squared, and we get 15x cubed. Then we do 3x times 6x, and we get 18x squared. 3x times negative 4 gives us negative 12x. And then we do the same thing with this bottom term here, right? This negative 2, we do it times 5x squared, we get negative 10x squared. Negative 2 times 6x is negative 12x. Negative 2 times negative 4 is positive 8. When we have all of the terms in the boxes, all we have to do are add them all up, right? So we're going to have to combine the like terms. 15x cubed, there's no other like terms, so that just stays on its own. Then we have this negative 10x squared plus 18x squared. That just gives us 8x squared. Negative 12x plus negative 12x is negative 24x. And then positive 8 is all on its own there. So our final answer is 15x cubed plus 8x squared minus 24x plus 8. And we could also use the box method to divide, just like here. So we have this 3x cubed plus 11x squared minus 14x plus 30. We're dividing it by x by 5. And how I kind of think of it is we know x plus 5 times something will give us this long function here. So we can write x plus 5 on the side of our box here, and we have to figure out what the top numbers are going to be, right? What the top terms are going to be, because we know x plus 5 times something will give us this long function. And what we do is we take the term with the biggest exponent, this 3x squared, or sorry, 3x cubed, and we're going to put it in the top left corner. Then we have to think, okay, I know x times something will get me 3x cubed, and that something is just 3x squared. So we write 3x squared at the top here, and then I can go like, okay, well, I have this positive 5 here. I know positive 5 times 3x squared gives me 15x squared. And then I look at my next term, and it's 11x squared. I already know I have 15x squared as one of my terms, and I got to think, okay, 15x squared plus something will give me 11x squared. Well, 15x squared plus negative 4x squared will give me that 11x squared. And we always put the like terms diagonal to each other, right? Once we have this negative 4x squared here in the box, we have to think x times something will get me negative 4x squared, and that something is negative 4x. Right, then we could do 5 times negative 4x, we get negative 20x. And then same thing, we have this negative 14x, and I know negative 20x plus 6x will get me negative 14x. All right, then I do x times something gives me 6x, and that is x times 6. All right, then I do 5 times 6, which is 30. All right, another way we can do this is we can use synthetic division, right, where we take the 0 of this smaller factor, right, the x plus 5, we take the 0, which is negative 5, and then we just write the coefficients of all of the terms here. So we have 3, all right, 3x cubed, then we have 11, then we have negative 14, and we have 30, just like we have here. We drop the 3, right, then we do negative 5 times 3 is negative 15. 11 plus 15, or sorry, 11 plus negative 15 is negative 4. So negative 5 times negative 4, we get 20. 14, sorry, negative 14 plus 20 is 6. Negative 5 times 6 is negative 30. 30 plus negative 30 is 0. Right, so these numbers on the bottom here, they represent the coefficients. Right, we have 3x squared minus 4x plus 6. Right, next we go into factor by grouping. right? So we have to factor completely, and we're given this function, and it's got 4 terms, right? So a good way to go at this would be to use factor by grouping, which if you remember, we start by grouping the first 2 together and the last 2 together. I know I just kind of covered up that one there, but that's okay. So once we group them together, we can start pulling out the greatest common factor, right? In this first one, the greatest common factor is x squared, which leaves us with 2x plus 5. In the second one, we have 12x plus 30, right? The greatest common factor there is 6, which leaves us with 2x plus 5. Now that we have this, right, these 2x plus 5s, they turn into a greatest common factor, so we can pull them to the front, which leaves us with x squared plus 6. Right? So number 4, we're using synthetic division. We have to see if x plus 3 is a factor of x cubed plus 2x squared minus 5x plus 6. And if we remember, how we do that is we take the 0 of this factor here, right? So the 0 of x plus 3, if you set that equal to 0, right, you'd get negative 3. We put that in the box in the corner. Then we just write out the coefficients. We have 1x cubed, 2x squared, negative 5x plus 6. All right, we drop the 1 and we multiply negative 3 times 1 is negative 3. Right, so we write that right under the next term. 2 plus negative 3 is negative 1. Then we do negative 3 times negative 1 is 3. Negative 5 plus 3 is negative 2. Negative 3 times negative 2 is positive 6. 6 plus 6 is 12. Since this remainder is not 0, right, not 0, it is not a factor, right? So x plus 3 is not a factor. Right, and number 5 is the same question, just with some different numbers, right? The big thing is first we take the 0 again, right? Since this is x minus 4, we have a positive 4. And one big thing to know with this one is it goes from x cubed to x, right? It skips x squared. So what we do is where that x squared would be, we just put a 0. Right, but then it just follows the same steps, right? You drop the 2, you multiply, you add, and you just kind of repeat that. But we get at the end a remainder of 0. And since it's a remainder of 0, we know that yes, x minus 4 is a factor. All right, so number 6, use the remainder theorem to find f of negative 5 for the function. All right, so the remainder theorem is essentially saying that we can use synthetic division and plug in this value of x, and whatever the remainder of that division problem is the value of the function. All right, so we take negative 5, we put it into the corner here, right? And then we write out all the coefficients. We have negative 3, we have 11, we have 12, and we have 7. Right, then we do the same exact thing that we did in number 4 and 5, right? We drop the negative 3, and then we multiply. Negative 5 times 3 is 15. We add these up, and we multiply again, right? And we keep going until we get a remainder. And since this remainder is 597, the function at negative 5 is 597. And if you wanted to check, you could plug in negative 5 into all these x values, and when you add them all up, we get 597. So let's look at number 7 and 8. Right? So these are sum and difference of cube problems, right? So we know the goal of these is to get it to look something like a cubed minus b cubed, right? Or in the case of number 8, a cubed plus b cubed. Because once we can figure that out, then we just plug them into that formula, right? That a minus b times a squared plus ab times b squared. And we remember this by that SOAP, right? SOAP. It's always the same sign, then the opposite sign, then the last one is always positive. So looking at 64x to the 6th minus b cubed, right? If I want it to be just something cubed minus something cubed, the b is already done, right? It's already b cubed. But this first term here, this 64x to the 6th, Well, I know 4 cubed is 64. And then if I'm looking at x to the sixth, if I remember my exponent rules, I can write it like this: x squared raised to the third power, because when I have a power raised to a power, I just multiply them together, right? So 2 times 3 gives me that 6. Okay, so I have my a term, I have my b term, so I just have to plug it in. A minus b, so that's 4x squared minus b, times a squared, right, which is 4x squared raised to the second power. So 4 squared is 16. X squared raised to the second power is x to the fourth, plus 4x squared times b, right, plus b squared. Right, and number 8's pretty similar, right? We have to figure out what is our a term, what is our b term. So looking at 8x cubed, right? Well, I know 2 cubed is 8, right? So that'd be 2 times x all raised to the third power, because x is already raised to the third power. So we don't have to do anything with that. And then we have 125 times y cubed. And if we think about it, we know 5 raised to the third power is 125. So we can rewrite this as 5 times y all raised to the third power. Right, then again, all you have to do is plug it into that formula, that a plus b times a squared minus a times b plus b squared. And remember, since this is addition, this is a sum of cubes. We have the same, so it's a sum, opposite, which is minus, and then always positive. All right, so let's keep going. Let's look at the next page here. Number 9, solve for the inequality. Express the solution in interval notation. Okay, so this we have to think of our steps, right? We have our inequality here. Step number 1 is solve the inequality for 0, right? So we can add 3x over, right? 6x plus 3x gives us this 9x. And then we can subtract 15 over. Right? Negative 20 minus 15 is negative 35. Right? Then we have to factor this. Right? So factoring it gives us 2x minus 5 times x plus 7. We set the factors equal to 0. Right, and then we solve, right? For this first one here, we get x is equal to 2.5. For the second one here, we get x is equal to negative 7. Right, then we draw those on a number line. So notice we have the number line here, and we have negative 7 plotted, and we have 2.5 plotted. Right, then what we have to do is we have to take a number in each of these intervals. Right, we have to take one from negative, something that's less than negative 7, something in between negative 7 and 2.5, and something greater than 2.5. And we test those with the original inequality. Right? So here, let's say we know negative 8 is less than negative 7. So if we test that, if we plug negative 8 into our original inequality, we get 60 is greater than or equal to 39, which we know is true. So we'll write true above it. We can test 0, because that's in between negative 7 and 2.5, and we get negative 20 is greater than or equal to 15, which is not true. That is false, right? And then we can test 4, because that's greater than 2.5, and we get 36 is greater than 3, which is true. So the only intervals we care about is anything less than negative 7 and anything greater than, less than or equal to negative 7, and anything greater than or equal to 2.5, right? Because remember, this is greater than or equal to. So we have negative infinity to negative 7, because remember, it's anything less than negative 7, all the way to negative infinity. And we put a bracket around negative 7 because it's greater than or equal to, right? And that's with this 2.5 to infinity. And again, we have brackets around 2.5 because it's greater than or equal to. All right, so let's keep going. Number 10, almost done here. We got 2 more. This one's nice because it gave it to us in factored form, and it's already solved for 0, right? So we get to skip a couple steps, and we just have to set the factors equal to 0. So for this one, we have x equals 0, we have x equals 9, and we have x equals negative 5. Then we just follow the same steps as before, right? We plot these on a number line, and we test values in between each of the intervals, right? So we want something that's less than negative 5, something in between negative 5 and 0, something in between 0 and 9, and something greater than 9, right? So if you test -7, you end up getting a false statement, right? So we write false. If you test -3, you get a true statement, right? 72 is greater than 0, so we'll write true up there. If you test 4, you get a false statement. And if you test 11, you get a true statement. So we only care about where it's true, which is in between -5 and 0, and then anything greater than 9. Now notice, this is just greater than 0. It's not greater than or equal to. So we want to use just parentheses. We care about the numbers in between -5 to 0, and also anything from 9 to infinity. All right, last one. So here again, it gave it to us in factored form. So all we have to do, set the factors equal to 0, right? This we get x equals -6. For this factor, we get x equals 4. Plot them on a number line. So we have -6 and 4 on a number line. And we just test, we want a number less than -6, something in between -6 and 4, and something greater than 4. Right, so we can test -8 because it's less than -6, and you would end up getting -48 is less than 0, which is a true statement. Then we can test 0 because it's in between -6 and 4, and we end up getting -144 is less than 0, which is also true. And we can test 6, which we get 288 is less than 0, which we know is false. All right, so we only care about numbers that are less than -6, and then numbers that are in between -6 and 4. Now notice though, because this is less than, right? It's not less than or equal to. We can't say that -6 is part of this interval, right? So we want to say we want numbers from -infinity because we want anything less than -6 up into -6, which is why we put that parentheses there. So that means we're getting super close to -6, but we're never touching -6. All right, we also want the numbers to the right of -6 all the way up to 4. All right, so we have parentheses around all these as well. Great job, guys. If you have any questions, feel free to reach out.